to show how Lapiz events can be used to manage the architecture of somewhat complex applications. The one we're going to be looking at is my Moonjumper task management system. I'll put a link both to the app as well as to the GitHub repo. The complexity that arises is that performing any one action can result in an AJAX request back to the server, and we don't know what the AJAX response will be. In a naive conception of the system, one would think that if we update a task, the only thing we're going to get back from the server is a copy of that task with the updated data. But there's things that the system can do that are interesting and complex. For instance, marking one task complete can activate several other tasks. So we may update one task by marking it complete and receive back 3 other tasks that have now had their status changed. Managing a system like this can get very complex, and the traditional system of callbacks can be difficult to manage. So I want to show how this gets managed in Moonjumper. The first thing that we should say is that every response from the server comes as a JSON array of objects, and every object from the server has a class attribute that tells me what it is. We then have this list of receivers, and the receiver is the type of class. Some of these classes aren't actual classes in the sense of we have them in the application or on the server, but they're instructions, for instance, task delete or label delete. This right here is the section of code that really manages all of this. The receiver receives a request, parses the data, and then goes through each and hands it off to the receive object. The receive object checks if we have a receiver for it, and if we do, passes the object into the receiver. That's the entirety of the code. Now, moving down the line, the reason this is possible is because of the way that the Lapiz events work. This line right here registers the receive function for the status 200 event. So every time an AJAX request comes back, it fires an event for status 200 if the status is somewhere in the 200 range. Now this will be any 200 status, 201, 202, but generally a 200 status is actually mapped to the actual 200 value. Going down the line, the way that this also helps us is that things like task upsert is a small, simple function that, depending on its outcome, can fire further events down the line. Let's take a look at that. So this is the task module, and using modules allows us to map the dependencies. Let's find our upsert function. It's right here. And the upsert function is pretty simple. We get the ID from the JSON we're receiving, and if we have a task, then we take it and update it, and if we don't, we create a new one. I mean, that's pretty much the definition of upsert. Now, in either case, we're going to end up firing events. If we create a task, then the class event for task creation will fire. If we update a task, that task's update event will fire. Now, the tasks themselves end up being a fairly simple class. Mostly they're a property bag. We can see the properties here. We have a few other things that get defined. We, wrap up the delete stub for the delete event. And then we've added a couple useful getters. Is this in a group? Is it in a group layer? If it is in a group, return the group. Things like that. This little section right here is actually linking into the group layer, and if this changes to be in a group layer, it forces the group layer that it is in to fire. We don't need to worry about that. It's a relationship matter that task can link to group layer, which can link to group. And so if we add a task to a group layer, we need to change that. And then the group layer down the road will fire the change event on the group. Now this task object ends up being pretty simple because all we're trying to do is encapsulate the logic that is purely part of the task class. We're not trying to encapsulate any of the interaction logic. The reason for this is that I've separated out the task interaction logic into this task view, which ends up being a much more complicated class. So this line right here is defining the view model on the task. So this maps to task.viewModel is now a constructor, and we can pass a task into it. But we never actually end up calling that, and I'll skip down to the bottom to show you why. This line right here is kind of where the magic happens. Although I say that, it's really not that magical. It's a pretty simple concept. The task class has its own event space, and one of the events that it ships with is create. So every time a new task is created, this event will fire. And what we do is we say, well, every time that event fires, call the view model. And the create event will pass the new task in. So this is saying every new task, call task.viewModel new task. That's simple. Now, I don't want to get too far into this logic because this is where it starts to get into a lot of the gory details of what the UI looks like and a lot of the edge cases that are sort of a pain to deal with, and there's no clean way to get around them completely. But by isolating those details into the view model, I'm allowed to keep the task object very clean cut. This also means that I can reuse the task object in a different interface. So for instance, the interface that I've built here is really not a terribly mobile-friendly interface. So I could potentially reuse this logic for something that was really oriented at small screen devices. It's also got a sort of futuristic flair to it. That might not appeal to everyone. I could create another interface that looked like a little bit more of a traditional business application. Doing it this way allows me to only rebuild the actual user interface section without having to rebuild anything dealing with either the communication or the actual task logic. At this point, we kind of come full circle, because it's UI events that will kick off communication events. Those communication events live down here. They're pretty simple. For instance, this method right here completes a task, com.task.complete, and all it needs is the task ID. At which point it kicks off an AJAX request to the server, task put, and it gives it the task ID and a complete status of 1. We don't include a callback here because, as we said at the beginning, when the callback comes through, if it's a 200, it'll end up in this receive method. The receive method will parse the data, send it into here for each object, and those objects will end up being routed to their receivers. So this is one way to use Lapiz to cleanly organize a structure, cleanly organize the architecture of an application using events. And note that we've created a very flexible set of tools to interact with our server API that can be easily reused and has created a clean abstraction of communication, object logic, and UI logic. Thank you.